Hello everyone. Now since we have already discussed the fluid static, the first part we're going to discuss. So here the first part of fluid statics, and once we are talking about the fluid statics, so the first question is rotating fluid. Let's say the beaker having height h, and once it got rotate about the fixed axis. Let's take the fixed axis omega about it is rotating, and you know very well the whole water surface got splitted into two surface. Now these are the portion where the liquid got filled up with, and this is the portion where air exists. So as you know, the level of the liquid or fluid got increase a bit. So here we can say maybe the question might be asked what portion. Let's say my beaker is up to height h. Fine. So once my beaker size is up to height h, what will happen? The remaining fluid, after rotation, it got spilled out. So maybe in your examination they will ask what volume of the fluid got spilled out, or they might be like beaker has very significant height. So this is a shape that is called paraboloid shape form, and maybe they will ask what is the next height of it. So let's say the next height is y. So there's a formula that you better to remember, because after derivation we have derived this formula: y is equal to omega square x. X is the new radius of it, or we can say radius or earlier situation, and afterward will remain same though, because this is a limiting condition when we can able to expose the bottom of the vessel. So this x, and here let's say this x, it will remain same. So y is equal to omega square x square upon 2g. So by this way they might be asking either y or omega or x. These three parameter they might be asked. So I thought situation is very much clear. The fluid once rotating, this is the original situation. Once rotating, the fluid shape will become paraboloid, and paraboloid the next vertical height, that is y, we can calculate by using the given formula. Clear? So you better to remember this situation. Now next situation is that is lateral pressure across the walls. Lateral pressure, this is very important because earlier it was asked already. So lateral pressure, let's say rho 1 and next rho 2, these are the two density profile, and having rho and 2 rho respective value, area remain a. So the first segment, the f1, would be, you better to say as, like, let's say the bottom height is h. So kindly take the average of the pressure at this height. The pressure, liquid pressure, would be how much? Rho g h divided by 2. This is the average pressure. Always remember the bottom surface, you will calculate the pressure, take an average of it. So this is called as average pressure, multiply by area, I'll get the average force at first segment. Now what about the force? What about the force across the second segment? So here we can say second segment having force. Once again, what about the lower height of it? Let's say from this end we take the reference to next height, it will be once again h, because this is the middle portion of it. So middle portion got filled with, forget about the upper portion of the liquid, you can say from this middle intermediate point to the bottom of it, once again h height, it got filled with 2 rho. So what is the average of it? 2 rho g divided by 2. But the earlier the rho request is already filled to it, so we can say the pressure will be rho g h plus, please remember this is average of it. Average bottom will, you have to take an average pressure, and whatever the pressure liquid that is over it, it will be